Hello and welcome to the holiday edition of our video roundup. I'm Will Knight and I'll be taking you through the top 5 tech videos of the year. You may have your own favourites, but these are the ones that got the most clicks. And at number 5 we've got a giggling robot that gets on very well with toddlers. Researchers at the University of California in San Diego are the first to observe how toddlers interact with robots over a long period of time. This robot, called Curio, was developed by Sony. It has sensors that prevent it from bumping into objects or kids, it giggles when someone pats its head, and it lays down when its batteries die. The children bonded with Curio over time, treating him like a human friend. They patted his arms and hands and often hugged him. When Curio lay down after running out of power, children would come over with a blanket and say night-night. Curio the robot looked pretty human to those kids, but at number 4 we've got some robots that don't look very human at all. In fact, they all look like animals. Swiss researchers developed a model of a salamander's spinal cord and created a similar system to control the movement of their salamander robot. It receives electrical signals from a wireless laptop that can tell it to switch from swimming to walking to change speed or direction. Nature helped these scientists, but it turns out that their robot also helped neurobiologists understand four-legged locomotion. Here's a video showing robots and cockroaches interacting. Belgian researchers found that robots that smelled like cockroaches were able to control the mixed group's choice of shelter. Cockroaches select a hideout based on how dark it is and what their fellow cockroaches are choosing. The robots were programmed to prefer lighter hideouts and were able to sway the cockroaches in the group. Here's another group, but this one is made entirely out of robots. M-Tran is a robot made up of many modules that can move individually and communicate with each other to change shape. Its computer uses genetic algorithms to generate thousands of patterns of motion and choose the best one for its purpose. A more advanced version of the robot can detect obstacles on its own using a camera like an eye. Agility is not confined to earthbound machines. At number 3 in our video chart we've got some aircraft with some pretty mean moves.
This plane was developed by engineers at MIT and can take off vertically from a standing start. After hovering for a while, it returns to its starting point and lands vertically again. The craft is also able to switch from an upright flying position to a more conventional flying mode during flight. It can complete 3 laps of this 8-metre wide room in about 10 seconds. Engineers at Georgia Tech University have also created an Agile aircraft. Their helicopter uses new software that enables it to roll backwards and land on a 40-degree slope. Here you can see it flipping backwards and perching itself on a 60-degree landing pad. Usually helicopters can't handle anything steeper than a 20-degree landing because their rotors would be too tilted, causing them to lose balance.
Such manoeuvres could help helicopters land on moving targets like platforms at sea. Next up is something that's not quite so novel. In fact, it's 2,000 years old. At second place in our chart, Ben Crystal, features editor, tells us about a machine he made based on a robot created by the ancient Greeks.
I took my son's scooter and I cut the wheels off, and I took a couple of broomsticks and cut those up as well to make the axles, and I just used a couple of pieces of old wood for the main body of the robot, and all you needed then was some string and some lead weights, and that was it. The idea is to wrap the string around the axles, and for every wind that you put in one direction it will make the robot go forwards. If you reverse the direction of the string it will go back. You can also use pegs into the axle, and by winding first one way, going round the peg and then winding the other way, you can go forwards and then back. This string programming language is fairly similar to the kinds of languages used in modern programming. It allows you to program a robot to move forwards, to move backwards, to stop and to turn, and those are exactly the same sorts of commands used in modern robots. The main limitation on the robot is the amount of string and the length that the string can move with the weight, so that it will only work for a short period of time, which means that you can't make it perform very long, complicated maneuvers. But if you want it just to move 2 or 3 meters and perform some simple maneuvers, then it's perfect.
In case you're wondering, Ben's son did forgive him for chopping up his toy scooter. But now for our top video of the year. Last September, this solar-powered plane broke the record for the longest uncrewed flight. UK defence research company Kinetic launched Zephyr from a military base in New Mexico, and it landed 54 hours later. The previous record was attained in 2001 by the Global Hawk plane used by US forces in Iraq and Afghanistan, which flew for 30 hours 20 minutes. Zephyr is made for carbon fibre with paper-thin solar panels covering its surface. Its lithium-sulfur batteries can charge up enough during the day to get through 2 nights. Now it's time for me to take off, but before I do, I want to wish you all a very happy holidays from everyone at New Scientist, and join us in the new year for lots more tech videos and stories. See you in 2008.